Have you ever just stood in a library and wondered, how on earth does all this work? I mean, we're talking millions of books, articles, and documents. Well, it's not just about neat shelves, it's a story of incredible human ingenuity. It's kind of like a secret code, one developed over centuries to make sense of, well, everything we know. So let's crack that code and dive right into this surprisingly fascinating world.
I mean, really think about it. It doesn't matter if it's a library shelf or your web browser, we face the exact same problem every single day: information overload. It feels impossible, right? Well, the answer to that question lies in a series of really brilliant ideas that didn't just organize books, they totally changed how we think about knowledge itself.
You know, for as long as humans have been writing things down, I'm talking from ancient clay tablets all the way to the endless pages of the internet, we've been wrestling with one huge challenge. How do you organize a collection that just never, ever stops growing?
At first, the problem wasn't some grand philosophical question. Nope, it was way more practical. It was physical. The very first systems weren't designed to organize big ideas. They were designed to solve the simple, frustrating problem of finding a spot on the shelf.
And this is where we see the first great shift in thinking. Before we could even start to organize knowledge as a concept, we had to figure out how to organize the actual things, the books, in a way that made sense and, wouldn't fall apart the second a new book showed up.
The earliest method was called a fixed location system, and it's exactly what it sounds like. A book's call number was literally its address. A number like 2.4.6.25 actually meant room 2, Elmira 4, shelf 6, book 25. Super direct, right? You could probably find the book blindfolded. But this beautifully simple system had an absolutely fatal flaw.
And this right here gets to the core of the whole thing, the huge philosophical difference. On the left, with the fixed system, a book is defined by its physical spot, its address. But on the right, in a relative system, a book is defined by what it's about, by its subject, its idea. And that leap, that little change in thinking, changed everything.
So just imagine this. Your math shelf is completely full. With a fixed system, when a new math book arrives, too bad, it can't go with the other math books. It has to go wherever there's an empty spot, maybe next to history or poetry, completely breaking your beautiful subject grouping. Every single new book created total chaos.
And then, in 1876, our hero enters the story. A librarian named Melville Dewey. He was working at a college library, and he just found this constant reshuffling and renumbering of books to be incredibly wasteful. He just knew there had to be a smarter way.
And this was his masterstroke, the big idea. He created the relative location system. Suddenly, the call number wasn't an address anymore. It referred to the book's subject. A book on geometry would always be placed next to other books on geometry, no matter where they physically were in the library. You could slot new books in forever without breaking the system. The paradigm had officially shifted.
Okay, but here's the thing. Solving that physical problem actually uncovered a much deeper, much trickier conceptual one. Now that all the math books were together, how should we organize them? And what about a book that's about, say, math and physics? Where does that go?
This led to the next big thing: enumerative systems, like Dewey's own decimal classification. The goal here was super ambitious: to create a comprehensive map of all human knowledge, with a predefined slot for every possible topic. You'd just find the right number for your book, and then you'd mark and park it right there. Simple.
But, knowledge isn't really that neat and tidy. As one librarian so perfectly put it, these systems often prove square holes for round pegs. You're trying to jam this complex, multifaceted idea into a single pre-made box, and a lot of the time, it just doesn't fit right.
Let's take a perfect example, a book on the anatomy of dogs. So, is that a book about dogs, which is zoology, or is it a book about anatomy? An enumerative system forces you to pick just one. You have to choose one single aspect, which means the other one gets lost and becomes undiscoverable. Knowledge is multidimensional, but these systems were totally linear.
So this new, more complex problem, it needed a new kind of genius. And in the late 1920s, an Indian librarian named S.R. Ranganathan came along, and he was ready to tackle this exact challenge: how to classify complex, multidimensional ideas.
Ranganathan developed something truly brilliant called a faceted system, and he used this incredible analogy. He said a subject is like a cut diamond. It has all these different sides or facets. So instead of trying to find one single label for the whole diamond,
His system described each of its individual sides.
And this was the revolution. With a faceted system, you don't just look through a long list of pre-made numbers to find one that kind of fits. No, you analyze the book's subject, you break it down into its core pieces, and then you use those pieces like building blocks to construct a brand new, perfectly precise number that is tailored to that specific document.
He believed, and this is wild, that any subject in the entire universe could be broken down and described using a combination of just 5 fundamental categories. He called them personality, matter, energy, space, and time, or PMEST for short.
So let's just put them side by side. An enumerative system, like Dewey's, gives you this predefined rigid list, and your goal is just to assign a number. But a faceted system gives you a toolkit to build your own number. It's dynamic, and your goal is to tailor a number that fits absolutely perfectly.
Okay, now I know what you might be thinking. This is all just some fascinating but, dusty old history about libraries, right? Well, what if I told you these exact principles are what power the technology that you use every single day?
I mean, you can see the entire journey laid out right here. We went from simple physical locations to organizing by subject to breaking subjects down into their facets, and that path leads directly to the complex systems that organize the entire web today.
Think about the last time you were shopping online. When you filter your search by brand, then by size, then by color, then by price, every single one of those filters is a facet. You're not picking from a long list of pre-made shoe descriptions. No, you are building a precise query using the exact principles of faceted classification. You're doing it all the time.
Today, all of this has evolved into something even more powerful, called an ontology. The easiest way to think of it is as the ultimate web of connections. It takes that clear top-down structure of the older systems and combines it with the super flexible, multidimensional facets we just talked about. It's the engine that organizes the modern semantic web.
And that, right there, is the crucial takeaway. The incredibly complex algorithms that filter your Google searches, that recommend your next song on Spotify, that organize the entire internet, they are the direct descendants of a frustrated librarian just trying to figure out what to do with a full bookshelf.
This whole story is just such a powerful reminder that our ability to innovate really depends on our ability to organize what we already know. And it leaves us with this one big question to chew on. As our universe of information just keeps expanding and getting infinitely more complex, what will the next great paradigm shift?